Hi everyone, today we are going to study edge connectivity in graph theory. Each cut set of a connected graph G consists of a certain number of edges. Now this is a well-known fact that any cut set of a connected graph will consist of a certain number of edges, which when removed from the connected graph G will cut it into two separate components and hence disconnect that particular connected graph G. Now the number of edges in the smallest cut set. By smallest cut set I mean such a cut set which has the fewest number of edges among all the other cut sets is defined as the edge connectivity of the G. That means whatever is the smallest cut set, that cut set would define the edge connectivity of a connected graph G. Say for example, in a particular connected graph, with respect to that particular connected graph, you have three cut sets of that graph, each containing the number of edges 2, 3 and 4 respectively. Now obviously the cut set with the number of edges 2 is the smallest cut set. So hence the edge connectivity of the graph G would be 2 in that case. In case of a tree, the edge connectivity is always 1 because you remove even a single edge from the tree, it gets disconnected, because obviously a tree has only one path from any one vertex to any other vertex. So the removal of a single edge from the tree makes it disconnected. Hence the edge connectivity for every tree is 1 because that is the minimum cut set you can have in any tree. If I look at the edge connectivity of the graph shown here, then this graph has many cut sets. But out of all the available cut sets, the one with the edge K is the minimum or the smallest cut set. Because you see, when I remove this single edge K, the graph is cut into two separate components, one with the vertices V1, V2, V4 and V5 and other with the vertex V3. Just the removal of a single edge K divided or has cut this graph into two components. Hence, this cut set has how many edges? It has one edge. So the edge connectivity of this graph is 1 because the smallest cut set is with the edge K, which is just one edge. So the smallest cut set for this graph is with one edge. Hence the edge connectivity of this graph is 1. If I look at another example, you can see this is also a connected graph which has several cut sets. Now out of all the cut sets, we will consider only the smallest cut set. So this cut set, as is shown in the broken black lines, it is covering two edges A and B. So that means these are the cuts. This is that cut set which has the smallest number of edges, or this is the smallest cut set. And as I said, the edge connectivity of a connected graph is defined by the smallest cut set, that is the one having the minimum number of edges out of all the available cut sets with respect to that particular connected graph. So out of all the available edges, the one with the smallest cut set is this one having edges A and B. As you can see, if I remove edge A and edge B from this connected graph, it cuts this graph into two separate components, where in one component you have just one vertex V1 left, and in the other component you have the vertices V2, V3, V4, V5 and V6. So clearly removal of these two edges disconnects or divides this graph into two separate components, and these are the minimum number of edges required for disconnecting this particular graph. So out of all the available cut sets, the one with the smallest number of edges or the smallest cut set is this one with edges A and B. So as I can say that this is the smallest cut set, hence the edge connectivity of this particular graph is 2. So this is how you can find the edge connectivity of any connected graph. And in case of a tree, the edge connectivity is always fixed, that is 1.